My name is Frans. I'm a graduate student at the in Holland Composites lab here. I've been working on this project for the last 20 weeks and it's part of the Automated Composite Repair team. My part was to design a movement system for the ACR robot, which is designed to carry out repairs on the wind turbine blade. Basically what the system I designed allows the robots to locomote on a wind turbine blade in any position possible. It allows the robot to move from place to place on a wind turbine blade when the wind turbine blade is installed. Given the varying geometry of the wind turbine blade, it's necessary that this movement system allows the robot to, for example, hang upside down or sideways or vertically sideways. So I started my literature study looking into wall climbing robots. To design wall climbing robots, you need to look into two specific factors. One is locomotion, which is actually the way to move. The second is adhesion, which is in fact the way you stick to a surface. You can either design them separately and then combine them, or you can design one big system that incorporates the two. I chose in fact to design two separate and then combine them. For my locomotion method, I chose wheeled locomotion. I decided to go with mechanism wheels. Mechanism wheels, in fact, allow the robot to move in almost any direction very effectively and efficiently. To go along with the mechanism wheels, I chose suction cups. However, there remains a problem that suction cups, they resist shear, which is unwanted since we also want to locomote. To solve this problem, I added a small ring of Teflon to the bottom lip of the suction cup. This allows the suction cup to retain a normal force, a normal pulling force that keeps the robot against the surface of the wind turbine blade, but allows for a low shear force, low resistance to shear force, which allows the mechanism wheels to locomote the robot. In combining these two methods, we noticed that the locomotion method still performs as expected when moving back and forth. However, it has a little bit of problems when moving sideways, which was not expected. The most important conclusion that I made is that the 90-degree load case is in fact the critical load case. This is important for further optimizing the robot and designing the robot.